This is an ASPO question on factorising polynomials and trigonometric equations. F of x is equal to negative 3x cubed plus 8x squared minus 9x plus 10, where x is a real number. And the first part of part A part I, we want to calculate f of 2, which basically means we're just going to substitute 2 into f of x. So if we do that, we'll get negative 3. And that's going to be times by 2 cubed, and then plus 8 times by 2 squared, minus 9 times by 2 plus 10. Right, so we've then got negative 3 times by 8, so that's negative 24. And then 8 times by 4, so plus 32. And then minus 18 and plus 10. And that gives a value of 0. Part 2 of part A, write f of x as a product of two algebraic factors. So by what we've done in the first part of part A, we can say that since f of 2 equals 0, then x minus 2 is a factor of f of x, and that's by the factor theorem that we're able to say that. Now, I want to work out what the other factor is when this gets divided by x minus 2. So I could use long division. I think that's going to take too long. I want a quick, easy way to do it. So what I'm going to do is I'm going to say f of x is equal to x minus 2 times by something else. Now that something else needs to be a quadratic because it needs to multiply up to give me a cubic. So I'll write that quadratic as ax squared plus bx plus c, and I'm going to work out the values of a, b and c, because this is going to be equivalent to negative 3x cubed plus 8x squared minus 9x plus 10. Now the easiest ways to find two of the coefficients is to look at the first term and the last term. Now to get this negative 3, which is the coefficient of the x cubed, that will come from multiplying x and a x squared. So I've basically got a x cubed, when I multiply it out, is equal to negative 3x cubed, which leads to a equal to 3, or minus 3, sorry, minus 3. Right, so let's highlight that because we'll need it in a minute. And then look at the last term from f of x, which is this plus 10. And that's going to come from multiplying the negative 2 and c. So that will give me minus 2 times by c. So minus 2c is going to equal to this plus 10. Well, that leads to c equaling to negative 5. So I will highlight that because I'll need that as well. And what we're going to do now is move on to working out what b is. Now there's a couple of ways of working out b. I can look at the coefficients of the x squared term or the x term. I'm going to look at the coefficient of the x term and think about what needs to be multiplied out to give me that 8. Well, there's two sets of terms multiplied that are going to give me the x squared term, and that's going to be x times by the bx. Okay, so that gives me bx squared. And then also the negative 2 times by the ax squared, which will give me minus 2ax squared. So minus 2ax squared. And that's going to equal to that 8. X squared. Now I don't need the x squareds because this has got a balance. I've got b minus 2a is equal to 8. Now I've already worked out a, and assuming it's correct, that's negative 3. So b minus 2 times by negative 3 is equal to 8. That gives b plus 6 is equal to 8. And then it follows on that b is equal to 2. So that's my third value. So now I can say that f of x can be written as x minus 2 times by, now we'll replace the a, b and c in the identity that I set up, which was here, and replace those with minus 3. So I've got minus 3 or negative 3x squared plus 2x, so the b is 2, and then minus 5, which was the c. Using the answer to part A, which is this answer here, part B, prove that there are exactly two real solutions to this equation. Negative 3y to the power 6 plus 8y to the power 4 minus 9y squared plus 10 is equal to 0. Now, I need to make some comparisons between what I've been given here and what I had in f of x. And I noticed that the coefficients are the same. Negative 3, 8, negative 9, 10, negative 3 plus 8, negative 9, 10. But the powers, if I highlight those, which were x cubed, x squared and x, are now y to the power 6, y to the power 4, y squared. It's like I've basically taken the x out and replaced the x with y squared. If I do that, I'll get this. So that's what I'm going to do in part B. I'm going to take the x from f of x and replace it with y squared. I could write it like this, but I'm going to do f of y squared. So if I do that, then using my answer from part A, I will have y squared minus 2 in the first bracket. So every one of these x's here, just replace with y squared. Then in the second bracket, I'll have negative 3, and then it's going to be y squared squared, and then plus 2 y squared, just put it in brackets so you can see the substitution, minus 5. And we set this equal to 0 because we're solving this equation equal to 0. So if I were to multiply all of this out, I would get this equation here. So we're going to look at both parts and see if it has any roots. So we'll take the first part, which is going to be y squared minus 2 is equal to 0. So that's y squared is equal to 2, which gives y is equal to plus or minus root 2. Okay, so I've got two real roots here, which I'll highlight. Let's see if there are any more roots. And the way I'm going to do that is by looking at the second one here. And what I'm going to do is to work out the discriminant of this to see if it has any real roots. Now, if I'm going to work out the discriminant, so that's b squared minus 4ac. A is going to be the coefficient of the y squared squared term, so minus 3. B is going to be 2, and C is going to be negative 5. Right, so b squared minus 4ac is going to be 2 squared minus 4 times by negative 3 times by 4ac negative 5. So if we work that out, we'll get negative 4 times by negative 3 is going to be plus 12, times by minus 5 is going to be minus 60, so we get negative 54. So we can say that since the discriminant b squared minus 4ac is less than 0, and we've just shown it above, there are no real roots for the second factor or second bracket. Therefore, the only real roots are plus or minus root 2, as we showed here. And we'll just put as required because we were asked to prove that. Part C, deduce the number of real solutions for theta greater than or equal to 7 pi and less than 10 pi to the equation 3 tan cubed theta minus 8 tan squared theta plus 9 tan theta minus 10 is equal to 0. Now the first thing is that if I take the x from the very first equation f of x and I replace it with tan theta, I get this equation. So I could write it either as I'm taking the x, replacing it with tan theta, or you could say that really the equation we've got there is f of tan theta. And I want to work out how many solutions this tan equation has by using my x equation. Now, I don't actually need to find these solutions, I just need to state the number of these solutions. Now, I know that I'm not going to get any solutions from the second factor here because we've already shown that there are no real roots from this part. It's only going to be this part here. So I'm only going to get solutions for this tan theta, so just replacing x with tan theta minus 2 is equal to 0. In other words, when tan theta is equal to 2. Now I don't need to find the roots, but it's quite helpful. Maybe if we do the tan inverse of 2, what we get is theta is sort of round about 63 point something degrees. Don't really care too much, but what I'm going to do is to draw a cast diagram so that I can see how many roots there's going to be. So if I draw this 63 point whatever angle on my cast diagram, so it's going to be somewhere there in that quadrant, and I'm looking for solutions between 7 pi and 10 pi. Now whenever we've got we're trying to solve for tan, remember we draw a straight line, so there's going to be solutions in these two parts of the cast diagram. Now I just need to work out where 7 pi and 10 pi is. So all the odd numbers of pi are over here, like 1 pi, 3 pi, 5 pi. So you're going to have 7 pi over here, and then all the even values of pi on a cast diagram over here. So 0, 2 pi, 4, 6, 8, 10 pi over here. And my solution is in that range. So how far around the cast diagram do I need to go? Well, we start from 7 pi, and then we get to 8, 9, 10. So you can see that we need to go around the cast diagram a couple of times, or more than once, to get round to 10 pi, because first time we go around it's going to be 8 pi, 9 and then 10. And all of these points of intersection here are going to be where my roots are. So 1, 2, 3 on my solutions. So using that, I can state there are 3 real solutions to the equation. So it's a combination of using a little bit of trigonometry to work out where the solution would be, my principal one, and a cast diagram, and just seeing where all those other roots would be.